All right, so this Friday is your midterm, and today is completely devoted to a midterm review. We're going to go over some of the basics for your midterm, but then also I've got last year's midterm right here, and we're going to go ahead and do it. And that's the review, right? So it'll include everything up into and including arrays. So if you didn't do too well on your array lab and or your hack, make sure that you are getting into help hours and fixing whatever was wrong, because that will really help you as far as studying for the midterm goes. All right? So the midterm itself, remember that we are online, so if you have any questions, you can post to Piazza or you can post to the YouTube live stream here. It's for this Friday. It's during your normal hack lab time in PKI 311, excuse me. And wherever the overflow room is right next to it, I think, or across the hall. In-person attendance is required. They will be proctoring. They'll be there, and they, as in the TAs, will be there, and they will be there to ask administrative questions and to ask clarifying questions, but they will not be providing the same amount of help as they provide in labs or hacks. When you get there, a handout and starter code will be made available, soft copy. In other words, they'll provide you with a link, and it's actually going to be a GitHub repo. If you want to, you can clone stuff, or you can just download the files, or if you really want to, you can cut and paste. I wouldn't do that, though. It's open book, open note, and of course, required computer. If you do not have a laptop, there are plenty of computers in PKI 311 to use as backup. All right. There's no collaboration, though, in or outside of class. So no texting, no chatting, or anything like that. We will be using this tool. I don't know if I've demoed it before. We can take a look at it if we have time. But it's called MOS, Measure of Software Similarity. It's really easy. All I have to do is throw everybody's code into it, and it comes back with this person matched with this person 95%, right? In other words, they just copied the code over. This person matched with this person 90%. You take a closer look, and all they did was change the variable names, right? So it is a code is, highly structured. It is super easy to find out who copied from whom. Don't try it, all right? Don't even be tempted to, all right? Submit. You can submit and resubmit as many times as you want through the web hand-in. And you can use the web grader and grade yourself as many times as you want, just like a normal hack, just like a normal lab. Right? Within that 2.5 hour period, you can do that as many times as you want. When 11:30 hits, that's when it will cut off. Right? So make sure that you are paying attention to the clock and that you are not turning things in at the last possible second, because it will lock you out. Right? It's graded on style, documentation, design, and correctness, just like hacks. Of course, weighted to 100 points instead. They're going to be 2 parts, so weighted to 50 points each. Right? Again, do not work at the last second. The hand-in will be cut off. Questions on the format? Yeah.
So, if we're like, halfway done with our code for like, say, part 2, and it's like 11:30, if we just turn that in, will we still get graded if we're only like halfway done, if we have like part of it right, or will it just automatically just...
It depends on how right it is.
So let's say it's like all completely correct and it's just strictly a time thing. How will that work? Will we just like...
Well, if it's all completely correct, you have nothing to worry about. But if you, it'll be kind of like the grader for Hack 7 with the arrays. We split it up into multiple test suites. Those test suites have multiple test cases. And points are awarded based on whether or not each one completes. And if it's only 50% are correct, then you get half the points.
Okay. I was just asking though, like, say there's like a function that you just like aren't getting to work, and it's like towards the end, but you have like
priority is make sure that it compiles
okay.
and runs. Absolute priority, because if you have 99% of it correct and then you forgot a semicolon because you didn't have time, that kills everything, right? So make sure that it compiles, period. Right? Okay. All right. Any questions on that? Nope. All right. Yep. It'll be similar to what I'm about to show you. It'll contain not a formal test suite, but like the examples in the handout will be given to you and say these have to pass. right? And make your own to make sure that it's working. All right, we give you something that you can then, fire up GDB or at least Valgrind on it and work with it, so you don't have to start from scratch. The format is very similar to what we did in fall of 2001 or 21, excuse me. It's one full basic program from scratch, and a basic input-output program, and then a bunch of array utilities here. Right? So we'll start on the program first of all. Let's go ahead and zoom in here. You don't have to know anything about baseball to understand what's going on here, because it's all just formulas that we give you. But this is something that's actually in any sports. It's called the Pythagorean Expectation. So you know all the Pythagorean theorem, a squared plus b squared is equal to c squared, right? You can actually use that theorem to predict, based on the number of points that a team earns, and based on the number of points that that other teams score against them. You can use those two things to estimate what the win probability or the win percentage is going to be, right? So in particular with baseball here, what we have is a Pythagorean expectation. It's a statistical tool that is, suppose that you have a number of runs against, right? It's just a score, right? Runs scored, excuse me, and then a runs against, right? And you can read more about it here in Wikipedia if you want to. The basic formula that computes a team's expected win percentage is as follows, right? So RS to the P plus RA to the P, right? It's just a basic formula here. And there are several choices of exponent that you can use. For example, if you choose P1 is 2, guess what? That's the Pythagorean theorem, right? A squared plus B squared is equal to C squared. It's just that you're taking one onto the other side as a denominator instead. Alternatively, you can use an empirical value that people have computed before to be 1.83 from historic data, so from 150 years of past baseball data. Another more commonly used formula for the exponent incorporates the number of games played. So for example, a full regular season is 162 games, and so what you could do is you could take the ratio of this thing, and then you could take the log base 10 of that. Remember, that's just the P, that's the exponent. This function has not changed. Right? Another value for P is going to be runs scored plus runs against divided by 162 raised to this 0.287. These are all going to be very, very close values to 2. In fact, if you compute these values for this particular example, 2, 183, 191, and 190. You plug those into the runs scored divided by runs scored plus runs against, and you get these values right here, right? So in other words, they should win about 41% of their games based on this estimation. They should win about 42% of their games based on this estimation, et cetera, et cetera. We're going to round to the nearest win based on a 162 game season. Right? So if I take each one of these and multiply it by 162, I get 67, 68, 68, and 68 predicted wins. Right? With these values, 705 runs scored, 839 runs against, and 71 games currently in the season. They actually won. We're going to report our performance as well. They actually won 71 games. You can invoke your program as follows. You will output the P value. You will output the win percentage. So there are those 4 numbers right there. The predicted wins, there are those 4 numbers right there, 67, 68, 68, 68. And whether or not it was correct based on this third value right here. 67. They actually won 67 games. In other words, they overperformed by 4 games. We predicted them to win 67 games. They've actually won 71 games, and so they have 4 games greater. Right? This is all just basic math. Right? All right. There's another example. 786 runs. I think that this is the Reds. They underperformed in 2021. They had 786 runs scored, probably the majority by Votto. 760 scores against, or runs against, and then they won 83 games. They were predicted to win 4 games, and so they underperformed by 1 game. Right? So it's just going to be this number, or this number right here, minus this number, and that gives you this 4th column right here. Right? Okay, so let's start at the top. Let's write a program that reads in those three numbers, computes these four exponent values, computes these four values based on EWP, and then outputs the table. Yeah?
So if I were to, this is just hypothetical, but if I were, and I don't even know if I need it for this, but if I were to like, in the exam, go online and look up like the math library, like their functions, would that be allowed? Or
Oh yeah, open book, open note, open computer, required computer.
Okay, so it's like open Google.
Yeah, you can Google.
Okay.
Yeah. There's nothing on Google that's going to help you if you don't know what you're doing. Trust me. All right. That's why it's allowed. Go ahead. Yes, do it. I don't require memorization, right? Remember, I don't remember what the derivative of sine versus cosine is. Which one is the negative, right? You put it on a Post-it note and you just read it there, right? What are the math library? What's log base 10 in the math library? I don't know. Look it up. We're going to have to look it up here in a moment, right? All right, so let's go ahead and create this program. I forget what the file name was going to be called, but we'll go ahead and just go wins.c, all right? And it's going to be a full program from scratch. So here's a tip. Have your previous code out and available to you so that you can copy paste some of the basic boilerplate stuff, which would include, say, author documentation, right? The date. Today is the 23rd. Right? You can even fill in you know when you're going to take the exam, you can fill that in beforehand. Midterm, win expectation program, right? Whatever, right? Come up with some better documentation than that. Right? I'm going to include the standard library, stdlib, right? Include the standard input-output library. Probably going to want to include the math library like you suggested, right? Because we're going to have log base 10, maybe a POW function, right? And int main, int argc, char argv, right? Return 0, right? And if I had a couple of copies of this boilerplate stuff sitting on my computer, then I just saved myself 5 minutes on the midterm. Great. We're expecting 3 command line arguments: the runs scored, the runs against, and the number of wins currently. So how many arguments should I actually be expecting? 4. And if it's not equal to 4, then I can go ahead and tell you that, right? Printf error or usage runs scored, runs scored, runs against, and wins. And the line, and then we can exit on them with an error. Right? Otherwise, I know that I have 4 arguments, so I can start converting them. All 3 of them were integers, by the way. Right? So int runs scored, right, is equal to a to I of argv of which one? Is it going to be 0? 1. Why? What's in 0? a.out, the executable file name. Copy, paste, paste. Runs against, right? Runs, or wins, right? Make sure that you change. Don't just copy, paste, change if you're going to copy, paste. Don't copy, paste to begin with, though. Right? All right, there we go. Now we're going to have to compute each one of those p-values, right? Each one of those p-values is going to be a double. So piece of 1 is equal to something. Piece of 2 is equal to something, right? Come back over here. What was piece of 1 again? 2, right? That's just a hard-coded value there. Another value is going to be 1.83. That's a hard-coded value as well. So 2.0 double piece of 2 is equal to 1.83. Double piece of 3. What was that again? Oops. Nah. I mean, if you wanted to, go ahead, but nah. Then you're gonna have to put the all the expectations into an array. You're gonna have to. I don't want to do it that way. You can do it. I don't think that we'd take off for that. So go ahead. It'll save you all of 2 lines of code when you go to print. All right. So remember that. Otherwise, if you want, I don't know if you can or not, but if you bring like another VGA cable or something like that, you could probably use one of the lab computer monitors or a dual monitor setup, right? Does anybody do that during lab? No? Okay, yeah, you do? All right. Ah, there you go. Right. HDMI, HDMI, hopefully. Okay, like nobody has a VGA output on their laptop. Okay. Oh, okay. Wow, all right. Cut and paste here won't work. Runs scored plus runs against, so I'm going to have to do that. But it's going to be log base 10. Does anybody know what that is? Maybe it's log 10. C, math, log 10. Hey, log 10. So log 10, and it's going to be runs scored plus runs against divided by, what was it, 162? There we go. Is that correct math? There's the formula again. Is that the correct math? I need parentheses on the numerator, denominator, numerator. Is that correct? C math. Integer divided by an integer.
No, because it returns a double.
Yep, so what do we need to do? Typecast, at least one of them. And then then add 0.045. Right? So double check. In fact, I can go ahead and, there's my dual screen now. 162 runs scored, runs against. Would RS or RA be appropriate variable names? Probably not, right? If you're a math person and that's a math formula, then sure. But that's not good coding style. Okay. P4 here is going to be the exact same thing, except not the log, and we take it to the power 2.87. So double P, so 4 is equal to this thing. And then what was it? To the 0.287. Is that right? 287. All right. Correct math or not?
Nope.
Nope. Same problem as before. First of all, integer divided by an integer is going to be an integer. Right? So typecast that. And then,
You need the POW function.
yep, I can't do this in C. I mean, I can do this in C. This is going to be a bitwise exclusive OR operator. And if you're into bit twiddling, then you will use that at some point. But that's not what we mean, right? We mean an exponent, x to the y. And for that, what do you suggest? How? Exactly. The first one raised to the second one. Done. Okay. All good so far? Looks like it to me. Those 4 different p-values then are, I mean, we could print them out and we could examine them and see, did we get these values for those input values that we set down there? How could we quickly do that without having to waste time doing a bunch of print statements? Actually, it's not a waste of time to do print statements because we will eventually be printing them out. So let's go ahead and do that. Right? Otherwise, I was alluding to what kind of tool can you run a program on and then examine values? GDB. Right? All right. I don't care about formatting, so I'm just going to go ahead and grab this thing here. Right? Printf, the first header, and the line. Printf. By the way, I'm cut and pasting from a PDF, which is generally dangerous because PDF will have Unicode characters and weird non-ASCII text characters. The handout for you guys will be actually Markdown, so cut and paste, no problem there. Yeah?
So, well, I guess it doesn't really matter anymore since it's a markdown, but I I was gonna say, if like your math and everything works out, but you don't have the formatting exactly like that, how much would we be off?
Well, I mean,
Off for that?
as long as it's just like a regular assignment, as long as it's readable, and as long as you're reporting at least as much information.
Okay.
If you want to go out to six figs, that's your business. Right?
Okay.
Right. So %F, the win percentage here, we'll go ahead and leave that as is, but we'll go ahead and go with P1, and then cut, paste. We're going to come back and add the rest of the data. Let's go ahead and make sure that it's working at least up to this point, right? So iteratively testing, ad hoc testing. GCC wins. Of course, I need to bring in the math library, LM. And 705, 839, 71. Remember that for me. 705, 839, thank you. I can only remember one number. And 71. There you go. Two. So what's wrong?
Are you rounding or are you?
What should they be?
It should be.
There we go. Right?
It should be doubles and then printing out.
They are doubles. And they're printing out as ints, yes. What's wrong? That won't matter. If you only want to go out to 2 decimal places, that's fine, but... Okay, there we... Oh, whoa. What was it before? Oh, okay. Usually it's %F. Yeah. Duh, thank you. All right, there we go. 0.2. If you want to go 6, that's fine. I don't care. All right, fine. All right. So I'm well, here, let's check. Are we good? Unfortunately, that goes over 2 pages. That looks good to me. All right. So what's the win percentage based on? It's all of them is going to be this formula right here. Right. So runs scored raised to the p-value divided by runs scored raised to the p-value by itself plus runs against raised to the p-value by itself. So let's go ahead and create all of those. Double. Yeah, okay, we'll go ahead and go with double. Yeah, it will be a double, right? And expected wins, say 1, right? This is the one time that I would say appending a number to a variable name is okay because they are all the same thing, right? We didn't attach a special name to each one of those exponents, right? Is equal to runs scored raised to the first p-value, right? But of course we can't do that, right? We have to go pow of runs scored raised to that p-value plus, and then in the denominator, same thing, plus runs against p-value, right? And did we get them all? There we go. Okay. Good? Nope, what's wrong? The POW will return a double, and this is an integer, and this is already a double. It'll be okay. Run scored will become, 708.5. Right? It's only when you're doing division that you have to be careful. Right? Copy. Paste, 2, 3, 4. And don't forget, if you are going to commit the sin of copy paste, make sure that you are changing everything. Right? If you just change a few of them, guess what? It won't work. I mean, it'll run, but it won't give you what you want. All right? Win percentage, %.2f. Or what do we go out to?
6.
Okay, so leave it like that. %F, 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 %F. I'd really like to know what code block mode looks like in Visual Studio here. Does anybody know? So code block mode is usually be like option command A, where you can select a column and then start typing and have the same thing type in multiple columns. No? If you can remember how to do it in Visual Studio, please let me know. Visual Studio on the web here. Right? Otherwise, expected wins 1, 2, 3, 4. There we go. Run it again. 41, 42, 41, blah, blah, blah. 6, 7, oops. Are we a little bit off here? Oh, what am I not doing? I'm not rounding for, here for the outputting, right? 41%, it's coming out to be 0.41. So if you want to match the output, you would multiply this by 100, right? You don't want to do that if it went before you've actually, computed the number of wins, right? So let's do that now. Int expected wins. 1, 2, 3, and 4. Let's do the first one first, though. So the expected wins is simply going to be this number times 162. If you want to use that number 162, fine, or you could put it into a constant, or you could put it into a define num games, right, to be 162. Oops, like that. And anywhere you used 162, you could replace that. 162, 162, and so this will be expected wins 1 times num games. Copy, copy, copy. 2, 3, 4. 2, 3, 4. Does anybody have the answer yet?
I couldn't find code blocks, but I did find you can do formatting with Shift Option F.
Shift Option F. Oh, nope. So there's a, now it's doing GNU style. Yeah, bleh. Gross. Expected wins 2. Copy, paste, paste. Right? 3, 4. Here, I'm going to fire up Eclipse, and I'll show you what I'm talking about just as an aside. Like say in most IDEs will support something like this. We'll let that run in the background while we're doing this, though. All right, so to print an integer, what are we going to need? Percent %d, percent %d, percent %d, right? GCC, oops. Double, but has int. Oh, not expected wins. It's going to be I screwed up. Oh, I called all my variables the same thing. Expected win percentage is what it is, right? Expected win percentage, expected win percentage, and expected win percentage. And then expected wins. Percentage, 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 and percentage. There we go. Of course, I couldn't use the same variables over and over again. I shouldn't use the same variables over and over again. All right. Something happened. Oh. Same mistake over and over again. Expected wins, expected wins. Should be expected win, percentage, 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 and percentage. 2, 3, and 4. There we go. 67, 68, 67, 67. Does that look right? 67, 68, 68. What did we not do here? Round. How do I round? Round.
I think it's Option Shift Select.
Option, shift, wait,
Like, click and
select.
drag with your mouse, or like click and drag on it with your mouse then. Or sideways, I think.
Option, shift. Oh, there we go. All right, you're in for some fun here. Option, shift. What did you say?
To select.
Okay. I have to. Come on. Option, shift. There we go. Round. That's what I was looking for. Option, shift, select. There.
But you can also select with your arrow keys in your command like you would normally as well.
Oh, what do you mean command?
Or the whatever it is to move the cursor around and select text. I forget what it is on Mac.
Oh, okay. I like Option Shift and then do whatever you're gonna do, right? All right, expected wins, let's make sure that that works. There we go. 67, 68, 68, 68. That looks good for that one. Right. Now all we need is the performance over here. Right. And you'll note here that I'm not putting a lot of white space in here. If you wanted to, you could, especially now that we have our nice little tool here. Come on. Option Shift. Nope. Option Shift. There. Lot over. Option Shift. Bunch over, however you want to do it. Right.
So that's better than copy, paste, page, and change it after the fact.
Yeah. Right. In fact, I wouldn't have done it like this, like all four at once. I would have done one and then did all my copy pasting. Right. But don't copy paste. Right. All right. So what's the performance going to be? Well, it's just simply the number of wins, which now this comes into play. Right. Is it number of wins? Let's see, the example here was 71 minus 67, so it should be wins minus whatever that third column was. So wins minus expected wins. Right? Or, again, using our trick, comma, wins minus expected wins, and we can't have everything that we want. It's not going to automatically detect that I want to go 2, 3, 4. There we go. But I can go ahead and you can also cut and copy paste stuff, right? You can cut and paste this, copy, and paste. Now come on. All right. Can't have everything.
If you put your cursor at the beginning of the line and you hold Option Shift and then down, you can it'll paste the line.
Option Shift down. This is good.
It'll paste the whole line onto the next line.
I don't like that. It should go into a full mode. For example, I mean here, like in Eclipse, we've got a trick here. I don't know, here's a bank account class, right? If you want to go into code mode, then you can stay in that code mode and you don't need to destroy your fingers holding down key combinations. And then you can do the same thing here. Or you can cut and copy paste a rectangular section and then post it somewhere else, paste it somewhere else. Undo, undo, undo. All right. I wish it were like a static mode that you could go into, but whatever.
What mode is it called?
Block selection mode. Each IDE will probably call it something different though. 4333, is that correct? Yay. So we got our first test case completely 100% correct here. What about our next test case? 786, 760, 83. So 786, 760, and 83. There you go. And that looks pretty close to me. 84, 83, yep. At this point, I'm confident enough that I could throw it into the grader and then see what happens. Right? I think it'll pass. If it passes 2 test cases, then it's probably going to pass the rest of them. Right? If you wanted to do some rudimentary error checking here, of course, you would have to check that runs scored is non-negative. Runs against is positive because, of course, you don't want to divide anything in the denominator by 0. But we're not going to look at. We're not going to. As long as you pass all the test cases on and do some rudimentary error checking, for example, checking for the correct number of command line arguments, we're going to be okay on this part. On the next part, where we do arrays, you need full error handling there. Yeah.
Are you going to ask us to do like specific error checking, like use an enumerated list for this, or whatever?
No, not necessarily. Just like for example, let's read about what the expectations here, because they're going to be very similar, if not the same. In this exercise, you'll implement several functions that operate on arrays. Write a function that takes an array and sums up its elements, but only if the element is positive. Any elements in the array that are negative should be ignored. Your function should have the following signature. The result should be placed in a pass by reference variable sum. For any invalid inputs, return a non-zero error value. So you don't have to use an enumerated type there. Anything else here? Place all of your prototypes into a header file, arrays.h, arrayutilities.h. Provide good documentation. Provide all your function definitions in a source file named arrays.c. We've provided a small tester file. I'll show you what that looks like here, but you don't need to hand it in, just the array utils. You should not have the opportunity to make the mistake of handing this in under Lab 7 or Hack 7 because those are closed. Right? But you could make the mistake of handing in Lab 7 code as your midterm. How will you know that you did that? By running the grader and seeing that it doesn't work. Right? Okay. All right. So header documentation. Just a reminder, actually I'll leave it in a to-do there. It's a good idea to have this documentation first because it tells you yourself that you understand what's going on. Don't just cut and paste from the handout. This function sums the given integers in the array, but only if they are positive. Right? Places the sum into the pass by reference variable. Right? This variable right here. We're not returning the sum. We are returning an error code. Right? So returns a non-zero error code for any invalid input. Okay? Let's go ahead and implement this. To do that, I'm going to need, output, there we go. Nope, terminal. I'm going to need a arrays dot or underscore utils dot c. Refresh this. There it is. I cut and paste the prototype, but then I provide a body. Right? So help me out here. You know how to sum things up, right? What do I need first? A total, right? Should I call it sum? I could call it sum because it says some positives here. Or total. Is it a good idea to leave a variable uninitialized? Nope. So, started at 0. For int I equals 0, I is less than size, I plus plus. Total plus equals whatever is in the array of I. Is that correct? We're only summing them if they are positive, so I need a if statement. If array sub I is greater than 0, then, and only then, will you do a total. No need for an else because you're going to ignore those. Okay? Return total. Nope. I put it into the pass by reference variable. How do I do that? Sum is equal to total. So the thing on the left-hand side is a pointer. You could, but then you'd have to dereference every time and make sure that you've got parentheses around it, and I don't want to do that. I want to keep it clear. So dereference sum and then set it equal. Right? You change the pointer into a regular variable so you can put a value into that regular variable. What did I forget to do though? Error checking, right? So what are some things that could go wrong here with the input? What about the first one? Null pointer. So if it's null, then that's a problem. Or if size is, or no, sum is null. Or what about size? Size is less than or equal to 0, I guess. But if it's 0, then you're probably okay because you're going to end up returning 0. Right? So if it's right, because of an empty array, the sum of all positives in that empty array is 0. That kind of makes sense. Right? I don't know if we tested for that last semester or not, but a non-zero error code, you don't have to get fancy. 42, just 1. Right. If there's no error, what do I return? 0. Let's take a look at the UTEL's tester over here. We have a print array and a print table so that you can, use those functions in your testing. We have the values in the handout, right? So, for example, over here, I guess the examples we have are down here, but we've got 8, -6, 7, 5, -3, 0, and -9. We call that function, right? Given this sum, we print it out, and it should be 20 if I did my math right? Is that right? 8 plus 7 plus 5, ignore 8, the rest of them looks like it should be to me. And so we check for that. Right? We can write more test cases if we want, but this won't compile right now, by the way. If we compile arrayutils.c, right? Oops, where's my array utils? Oh, arrays utils. Oops, I misspelled it. Move arrays utils into array utils.c. Or you could have come over here and rename somewhere over here. There, rename. Try that again. Uh-oh. Lots of errors, lots of errors? Yeah, errors. Null is undeclared. Let's come over here to our array utils. Cancel that. Refresh it. I renamed it. There we go. What do I need at the top here in a source file? Include. And where is null going to be? In the standard library. What else should I have included here, though? The header. Array utils.h. Am I using anything else like standard IO? There's no printf here yet. Am I using math? Nope. Right. So that should be good. Right. Great. Now we can go ahead and put it all together with arrayutils.o and array, or we can try to at least, the tester, but it's not going to compile because have we done append arrays yet or mult table, the other two exercises? No. If you want to, you can go ahead and, before you move on, you can go ahead and conditionally get rid of stuff, say, right? This will compile, right? Because you got rid of the code that tested the other two. It looks like 20 should be 20. I'm convinced it works. If you need to, write some more test cases during the exam, run it again, right, and try again. Right? We all know how to block comment, right? That way? Command back, / right? Command / Windows users maybe control shift / or just control / I don't know. Let's do the second one and we can test it. The second one is append arrays. Let's read the handout. Write a function that takes two arrays, A and B, and creates a new array that is two arrays appended to each other. For example, if I've got 8675 and 3009, then it should be 8675 309. As a result.
It's a good song.
That is what that's from. Good. Yeah, I think that was intentional. Right. It must have been. Right. All right. Suggestions? What's the first thing you should do? Error handling. So, if, what could go wrong here? A is null, or B is null, or size of A is null. Does that make sense? No, size of A is what? Less than 0. It's not a, it's just a regular old integer, right? You don't want to compare it to a pointer variable. So if it is less than 0, right? Or size of B is less than 0, then we will return, return what? What's the return type again? Pointer, so you're returning the memory address 1, telling me that you were successful and my array is over in memory address 1. That doesn't, yes, which is probably not. Right? Null. is what, for any invalid inputs, you should simply return null. And so we gave you explicitly what you should be doing in the exam. Right? Okay. Otherwise, we're all good to go here. I will, of course, need a new array. How big will that new array be? Yeah, before it was 4 and 3, so the new one should be 4 plus 3, 7. So int n is equal to size of BA plus size of B. Right? And let's call malloc. Int star, could I call it A? No. Could we call it B? No. C? Where do you think the programming languages got their names? Why is C called C?
It was the third one. A and B didn't work.
It was the one after B. Well, it did work. BPCL. What was next? Oh, C. Well, what came after that? C++, Y++, I++, ha ha ha, right? Or C#. Any music folks here? Right, so what's the note above C, or the half note, or whatever it's called, above C? Oh, above?
Above C.
Oh, well, yeah, but what is it, half note or fractional note?
C sharp. Yeah.
C sharp, and then B flat, and then B? Or, no, I don't know.
It'd be C sharp.
Okay, oh, whatever, I don't,
C sharp is also D flat.
I don't listen, I listen to music, I don't play music, sorry. All right, so, online they say D. And there is a programming language called D. And there's then keep going, and you get to a programming language called M, which is short for mumps, and it is used in really, really old medical record keeping situations. I interviewed for a job once where they didn't tell you that they were testing you for mumps, whether or not you knew the language, because they knew that nobody knows that language. They were just giving you this fictional language, and this is how it works. Write some code in that language, right? And it turned out that language was mumps, because it was a medical records company that I was interviewing for. Right?
That's a very interesting name. We're testing you for mumps.
Yeah, the mumps programming language. I think it's from, or M is Massachusetts General Hospital. I'm sure that it was somebody being clever. That's what all acronyms are, right? You come up with the acronym, and then you come up with the words that form that acronym so that... All right, so malloc. How big? Size of int times n, because I put that into the variable. Now I need to fill that array with the values. So for int I equals 0, I is less than... Let's do it on A first. So size of A, right? I++. We can just copy things over. C sub I is equal to A sub I. A is right here. B is what we're going to have to be careful with. Yeah?
If you were to, instead of putting size of A and size of B into a variable n, if you were to, like, write in malloc, put size of int times, and then in parentheses size of A plus size B, would that also work?
Yeah, that'll work. Either or. Oh. A sub I. So copying over A is no big deal. But now copying over C, we don't want to overwrite this over here. We want to start where we left off. So let's create another index variable here, J. And where should I start it? If there were, 4 things before, 0, 1, 2, 3, where should I start next? At 4. So I'll start it at size of A. And then I will run over each element in B. For int I equals 0, I is less than size of B, I++. I will put into C sub J, B sub I. What else do I need to do to make sure that I'm setting up for my next iteration? Here's 4. I copied this one right here. I need to now copy it over here and then over here. My index variable for that will be J. So size of A, 4, 5, 6. So I need to go J++. Okay? At the end, I return C. You could have called it result. You could have called it appended or whatever, right? Append arrays.
Can you iterate I and j in that third on your for loop?
Yeah.
Yeah.
Let's find out. GCC. I think with a comma. Oh, size of B. With a comma, not with a semicolon. Right. Oh, what am I doing? Of. I'm confusing myself. There we go. There might still be some problems here. Size of B. I get all of them wrong.
32.
There we go. Is that all? There we go. Yeah, it should work here.
Is there a reason you didn't do that?
I haven't shown that syntax, so I don't want to. I don't want to show you 50 ways of doing things and confuse you. Right? Just be straightforward. Right? Don't get fancy. Right? All right, compile it all together. Oh, did I? Yeah, I uncommented this part here. So we've got 1, 2, 3, 4, and we've got 8, -6, blah, 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 blah. So what should we expect here? We should expect, if I concatenate, or if I append the test array here, this part, and B together, I should get 8, -6, 7, 5, -3, 0, -9, then 1, 2, 3, 4 after that. Looks good. Looks good. Okay. Ship it. Right? That's better than good. Good enough. Of course, you'd put it into the grader, and it would run hundreds or thousands of test cases for you. You did this before. This is in Lab 7. After I gave it on a midterm, I incorporated that into Lab 7 last year because it was a nice little exercise. Write a function that produces a 2D array of integers that represents an n by m multiplication table. Your function should have the following signature. Mult table n m. For any invalid inputs, you should simply return null. Right? That makes sense. For example, if we have a 4 by n, it should be 4 rows and 5 columns. And it should be start at 1. So 1 times 1 is 1. 1 times 2 is 2. 1 times 3 is 3. 1 times 4 is 4. Right? All the way down to, what is it going to be? 4 times 5 is 20. Okay? So if you did this successfully on your lab, great. You can look at my solution instead. Right? Oh, and of course I should have been doing documentation over here as we went along. You can do that later. I'll leave the to-dos in there. So mult table. If n is less than, I think in this case we do want 1 because we don't want a 0 by 0 multiplication table. It doesn't make any sense. It would be empty. Right? So if it's less than 1 or m is less than 1, we will simply return null. Right? Okay? We did change the grader, by the way, for Lab 7 to accept either starting at 1 or starting at 0. So if you had zeros, that was fine. If you had 1s, that was fine. We accepted both. Right? I need to set up my memory first of all, right? How do I do that? Is it just a single array? Nope, it's going to be a multiplication table, so I don't know, table? Okay. Call malloc. But now I want size of not integers. Each row is not an integer. Each row is going to be a pointer to a row. So int star, space if you want to, times, and how many rows do you want? N. Then I need to go into a loop for int I equals 0, I is less than n, I plus plus. Each one of those pointers will point to a valid row of length m. Right? So table of I is equal to int star malloc size of int. It is going to be a regular old integer array for each row, right? Each row, five variables or whatever, times m. Once I've got my memory set up, I can now go into a separate for loop here. I'm going to actually steal this. There we go. For each row, for each column. J is less than n, j plus plus. Right. And I need to set table sub ij equal to something. Ultimately, I'll return the table. What is that something? So n and m never change, right? So this would be 20, 20, 20, 20, 20, 20, 20, 20, all over the place. I times j. Now remember, I am indexing on 0, and we expect it to start at 1.
I plus 1, j
Plus 1, plus 1. Good math? In parentheses. You can afford parentheses. There we go. You could, but then you'd have to subtract on your index. And then your indexes would be unclean. Gross. Oops. Okay. Yeah, I need to, there we go. And before, let's go, oh yeah, there we go. I did uncomment, so we're good to go there. And it should print out the table that was in the handout if we're successful. Ah. Almost. Go back over here. What's the problem? N rows, M columns. Right? There we go. Oh, I need to recompile everything, sorry. Right, there we go. And there we go. And we should be good. Now before I turn this, I mean, it looks like, right? It looks completely 100% correct. Before I turn this in, what's another way I could, you know, do a sanity check on this? Ow. I could, we could go ahead and change those numbers. What would a 5 by 4 look like? There we go. It looked like it was, you know, rotated or something like that, yeah. We could try it for 10 by 10. Do you want to try it for 1,000 by 1,000? Probably not. Ah, poor dump. Oh, what's wrong? 10 by 10. There we go. Right. But that's what I was about to get to anyway. That looks good. That looks like a multiplication table to me. Just ask a grade schooler, right? But otherwise, what was the other thing that I was alluding to that you could do a sanity check on? Yeah, val grind. Why did it fail when I did that? GCC. Is it going to work if I just compile it like that? G flag. Why G flag? Because it preserves the line numbers and variable names. Right? Oops, no space. There we go. And with the G flag there, A dot out, of course it's going to segfault val grind on A dot out. And I'll get at least a report about this on Y, right? And I can trace it back to after a block size 40 malloc, right? That there's something wrong with at line 52 here with print table. Right? So that at least narrows it down right here to you called print table from the main at line 36. So there's something going on around here, and then hopefully you see that you didn't change all the values that you should have. Okay. I don't have a tester set up for this, so, but I'm fairly confident that the way that we just did it, it'll pass all 100,000 test cases or whatever we run on it. Those are all randomized test cases. We didn't actually write those. Not in your main, because you're not even going to turn that in, right? It would be wrong to free the table here because you're returning the table. If you're going to trash it before you give it back, then there's no point in writing that function. Likewise with the array over here, right? Free it, don't free it if you want to in your own tester, but ultimately we're going to ignore that anyway. You're not even going to be able to hand that in because we only accept certain named files. All right, 15 minutes left. Any questions? Yeah.
Well, I don't remember what I was gonna ask.
Okay.
Lost it.
So I just did this in a little less than an hour, and I was talking you through it the entire time. Of course, I don't expect anybody to finish it in an hour. This was designed for 2 hours, and the way that I usually test things is I throw it at my TAs and say, "You do it," and you tell me how long it took you. If it takes me half hour to do it, then it takes them an hour to do it, and I figure that a student in the course maybe takes 2 hours to do it. And so that kind of, with the one that I gave to Adarsha, that kind of tracked, but you do have 2.5 hours. It should be doable. It is not as long as this, by the way. This is the one that you're doing is even a little bit shorter than this. I think you only have maybe 2 functions instead of 3. Don't quote me on that, I forget. And you don't have 4 things to compute. You just have, well, you do, but it's way simpler math. There's another question?
I was gonna ask you what you just said
Oh, okay.
about how long it'll be, if it'll be longer or shorter.
Yeah, I mean, you have the 2.5 hours. If you finish early, you can leave. No communication with anybody in the classroom at the time. Leave quietly, please. Don't distract anybody while you go. Yeah, if you only need an hour, then only take an hour and you're free to go. There's no attendance points. I mean, if you don't attend, then you ain't got the exam. We're not. I mean, they'll take attendance in that they'll take a head count and they'll take your names, but to make sure that everybody's there. But yeah.
Any common issues that you found?
Just forgetting the basics, not forgetting error handling, forgetting. Usually it's like hacks. It's a kind of an all or nothing kind of thing. I mean, it's not like a. I mean, code is so. Coding, software engineering, computer engineering, whatever you want to call it, is far less forgiving of small errors. So, for example, if you're a civil engineer and you were building you designed a bridge, and somebody forgot one rivet in the entire bridge, it's not going to collapse. You forget one semicolon in your code, and it collapses, right? So it's completely different beast, right? That bridge without that one rivet, that's going to pass with flying colors if everything else is perfect. But every 100% of your tests will fail if you forgot a semicolon and it doesn't compile. So it's very. I mean, I would be concerned if somebody is passing like 95% of the tests, or say 60% of the test cases, and not 40% of the others, because what's going on there, right? Now, on those testers where we had 1 million test cases, there were people that were passing 99% of the test cases, and we gave proportionate points, but they were failing 1%, but simply because they had one function wrong, but that was only like 100 out of a million test cases that we tested for. So you make sure it compiles, make sure it runs. If you don't get to a whole function, don't leave out that function causing it not to compile, right? Have it return some dummy value so that it at least compiles. Yeah?
Will the web grader kind of tell us, like, if we fail a test case, will it tell us, like, give us...
It'll be like Hack 7, where not as expected, here's the expected, here's the actual, right? Stuff like that. Now, of course, if you've got a seg fault or something like that, or you error out completely, then there's nothing we can do about it, right? Last one? Yeah.
How much help, if at all, will the TAs be? Will they be of no help to us?
I mean, they'll be able to, if I screwed up and Adarsha already went through, and so we have 2 solutions tested against each other. I think that it's 100%. But if I screwed up somewhere, then they can, make that determination and contact me really quickly. I'll be on call.
Help during, like,
No, 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 they're just administrative or clarifying questions. Right? They're not going to, you know, tutor you on GDB in the middle of an exam. No other questions? All right, so remember that it is 100 points, so it's about 11% of your final grade. So, I mean, it's not like, I don't know what calc is these days, but it used to be that there are 3 exams and each one was 30% of your grade. So it's not as summative, they call it summative. It's not as summative as some exams, but it is substantial, so, you know, do your best. Make sure that you arrive early and get yourself set up. Don't forget your power cord. Have a backup plan. For example, you are using the CS50 IDE. You can at least save your files if you completely, you know, your computer blows up for some reason, right? Switch over to one of the lab computers really quickly. All your stuff is still saved on the CS50 IDE. Right? You'll still be able to log in. Bring your phone for two-factor authentication, right? Don't forget anything. Okay. All right. Good luck.